Hello everyone, our today's topic for the chemistry A level with the subject code 9701 is the Gibbs free energy and work. What is the relation between Gibbs free energy and work? The mathematical form of Gibbs free energy, which we have already learned, that is delta G naught is equal to delta H naught minus T delta S naught. All these are measured at the standard states. Rearranging the above equation, we can easily put this negative T delta S naught and we can add on this side. The equation will automatically become delta H naught equal to delta G naught plus T delta S naught. Now this equation is split up into two parts. One part is delta G naught. This much amount of energy is available for the work. But this part of the Gibbs free energy that will not be available for the work. This much amount of energy will be utilized by the particle of the medium through which we are applying energy for the work done. This much part will not available for work done, and this much part will be available for the work done, and sum of the both is equal to the enthalpy change. For example, if we are burning petrol in a motorbike for the motion of the motorbike, simultaneously some part of the fuel consumed is also changing into temperature, into sound, and to different forms of energy. Automatically that much amount which is utilized in these different forms, that will not perform a useful work. That's why the part of the total enthalpy change of a reaction of fuel, definitely that will be not available for the work done, and that part will be T delta S. The product of temperature and entropy change. Temperature will also be changed by the change of enthalpy, and automatically the arrangement of the particle or the medium will also be changed. That is called as degree of disorderness, that is called as entropy. Now the entropy will also change, but during this dispersion of energy for these purposes will not be available for the work done. Only this part will be available for the work done. That's why the total enthalpy change cannot be converted into 100% work. Some part of the work is not performed, and some part of enthalpy is utilized in increasing the entropy. Now, next is Gibbs free energy change and the direction of reaction. Now, two things are important to mention here. For example, if the standard molar enthalpy change of a substance is negative, then definitely the substance formed will be stable one, will not be decomposed easily. But for those processes, for those compounds, if the standard molar Gibbs free energy is very small negative or a positive value, that will indicate that the product form are unstable or most likely to be decomposed quite easily nearly at room temperature. Now, some definite points we have already learned, that if our reaction is in equilibrium, if we consider our reaction in equilibrium, we have to consider these points. Number one, for example, number one, if reaction is in equilibrium state, definitely the total entropy change will also be zero, and automatically the total Gibbs free energy will also be zero. G naught will be zero. Second, if the delta G naught value is negative, if it is negative value, negative small, it means that the reaction is feasible, reaction is spontaneous and can be performed in forward reaction quite easily. And if the delta G naught is a negative large, then it indicates that the reaction is almost completed and the reactant has been shifted into the products and no sufficient amount of reactants left behind. Both of these values mean. But if the delta G naught is positive, but it is small positive, this will indicate that the reaction is going to perform rapidly and the reaction will slowly convert into the product. But if the delta G naught is large positive, this will indicate that the compounds are less stable and they will return back into the reactant and will remain in the form of reactant for a longer time. This is all about how entropy and Gibbs free energy can also explain, can also mention the direction of reaction and how the different parts of standard Gibbs free energy are available for the work done or which are wasted. I thank you all.